بسم الله الرحمن الرحيم. نبتدي البوستر سيشن اللي جاي بعنوان Chemistry and Clinical Pharmacy. احب في الاول ان انا اشكر اللجنه المنظمه للمؤتمر على المجهود الرائع اللي بذلوه امبارح والنهارده، وان شاء الله بالتوفيق والنجاح. عندنا 10 بوسترز. اول بوستر الدكتور حجاج عبد الله بعنوان Synthesis of Sulfated Lactosamine Containing Tetrasaccharides, the contribution of sulfate to the binding affinity of galactines. البوستر الثاني بالدكتور صلاح عبد العزيز Design Synthesis Biological Activities of New 2,5-cyano-1,6-dihydro 6-oxy-4-phenyl pyrimidine 2-thiol N-4-phenyl thiazole 2 acetamides. البوستر الثالث الدكتور عزة هشام بعنوان Optimization of a sensitive and robust strategy for micellar electrokinetic chromatographic analysis of sofosbuvir in combination with its co-formulated hepatitis C antiviral drugs. البوستر الرابع الدكتورة هند عبد الوهاب Design and Synthesis of some 1,3,5-tri substituted oxyindole derivatives as potential CDK inhibitors. البوستر الخامس بعنوان الدكتور محمد عبد العال Design, Synthesis and Biological Evaluation of New ciprofloxacin piperazine N4-carbamyl functionalized derivatives.
البوستر السادس لكيمست اسلام سالم مرعي بعنوان Synthesis, crystal structure, fluorescence properties and the anti-cancer activities of some new polysubstituted 5,6,7,8 tetrahydroisoquinolones. البوستر السابع للفارماسيست ندى يحيى بعنوان Rapid and non-invasive determination of certain metronidazole combinations by FTR spectroscopy. الثامن دكتور احمد فريد towards understanding of different solid forms of rheumatoid fumarate combined computational and experimental approach. البوستر التاسع دكتوره مروه ثابت how quinolones antibiotic resistance develop. البوستر الاخير دكتوره ساره صالح randomized interventional study assessing the efficacy of vitamin B complex plus alpha lipoic acid as neuroprotective prophylaxis in reducing the development of oxyplatin induced peripheral neuropathy.
So this is a poster presentation of my work, Synthesis of Sulfated Lactosamine Containing Tetrasaccharide, to study the contribution of sulfate to the binding affinity of galactine. So I will use the cursor here in red color. As you know, this poster presentation, so I have limited time, about 5 minutes for my presentation. So there are type of lectin. Lectins are carbohydrate binding protein. There are several classes of lectin. One class is galactin. So galactin is subclass of carbohydrate binding protein. There are several members of galactin, about 15 members. They are classified according to the binding site. One binding site. Some member of galactin contain 2 or more binding site for ligand, for their ligand. Galactin, this is from the name, they are galactose binding protein. So the main ligand for binding must contain galactose unit for binding. This is the prototype for galactin family, LACNAC with its lactosamine unit. This is the binding site of galactin with LACNAC. Here is the unbound carbohydrate recognition domain. Galactins as a family are involved in pathogenesis of several diseases, in particular cancers. Actually, laboratory of Dr. Lin are interested in studying of galactin lectins, galactin ligand. They synthesized several tetrasaccharides This one unsulfated. This one is sulfated at 3 position of galactose unit. This one disulfated at 6 position of glucosamine unit. So my target in continuation of this study, it is required to synthesize tetrasaccharide, specifically sulfated at 6 position of galactose unit. So this is disulfated. Important point here is the challenge to prepare specifically at this position, 6 position of galactose unit, and also attachment of linker. This linker is required for during biological screening. So for retrosynthesis, we can propose a synthetic scheme based on the structure of the tetrasaccharide. So this tetrasaccharide, we can imagine disaccharide donor with disaccharide acceptors. So each this lactosamine unit and this also lactosamine unit, they are composed from the same building block. This is galactose donor with glucosamine acceptor. So the synthetic scheme started with the synthesis of galactose donor through 4 steps, then synthesis of glucosamine acceptor at 4 position, then disaccharide glucosidic linkage to get this disaccharide. This disaccharide is removal of paramethoxyphenyl group, then activation by nitride. So this is disaccharide donor. To prepare the terminal LACNAC, also the same as glucosamine unit. This removal, selective removal of this group to get 4 position free. Then glucosylation to get the terminal LACNAC unit. So this is the disaccharide acceptor with disaccharide donor to get the tetrasaccharide. This step followed by removal of trichloroacetamido. This one was added to increase the ratio of beta isomer. Removal of trichloroacetamido, then under the same condition, introducing of stylo group to get acetamido derivative. Then, as you know, this is the main step now is how to specifically radioselectively introduce sulfate unit at 6 position of galactose. So there are many strategies and many trials were done, but the most successful one, strategy one, was to remove cleavage of benzyl group or debenzylation, reductive debenzylation, then followed by acetylation, introducing the linker, then full acetylation, then selective removal of silyl group followed by silylation, and finally to get the sulfated disaccharide, tetrasaccharide. The main problem here was some cleavage of silyl group was occurred during reductive debenzylation. So another strategy were tried. Strategy 2, this one involved removal of selectively removal of silyl group followed by sulfonation, sulfation followed by sulfation, then removal of debenzylation to remove benzyl group here, then conjugation to get the linker, and finally removal deacetylation to get the target compound. The structure of target compound was confirmed by 1 and 2D proton NMR and the high resolution map. This work was done in laboratory of Glycoscience Institute of Biological Chemistry, Academia Sinica, Taiwan. Assalamu alaikum.
بسم الله الرحمن الرحيم. Design, synthesis, and biological activities of new 2,5-cyano-1,6-dihydro 6-oxo 4-phenyl pyrimidine 2-wyl-thio N-4-phenyl thiazolo 2-wyl acetamide derivative. Poster presented by Associate Professor Salah Abdulmuttalib Abdulaziz. Introduction: the interest in thiopyrimidine carbonitrile derivative has increased due to a wide range of biological activities such as antimicrobial, antiviral, antiprotozoal, anti-tumor, anti-inflammatory, antioxidant, and anti-diabetic activities. On the other hand, 2-amino-1,3-thiazole derivatives had been reported to exhibit several biological activities such as antimicrobial, antiprotozoal, anti-inflammatory, antitubercular, and anti-cancer activity. In the same manner, for 2-amino-1,3-thiazole, some antibacterial sulfonamide as sulfathiazole, even range of cephalosporin and monobactam antibiotics contain in its molecule 2-amino-thiazole moiety. The scope investigation supported by the aforementioned biological activity for 2-amino-thiazole and 2-thioctopyrimidine carbonitrile. The goal of the thesis to prepare hybrid containing 2-amino-thiazole and 2-thioctopyrimidine carbonitrile linked together through 2-thioacetamide linker, with the goal to development many active anti-tumor and anti-inflammatory agent. Synthesis. According to scheme 1, the synthon compound 2-amino-thiazole derivative were prepared by reaction of thiourea with substituted acetophenone derivatives in presence of iodine. Further purification to give 2-amino-1,3-thiazole derivative, which reacted with chloroacetyl chloride to give 2-chloroacetyl amino-thiazole derivative. On the other hand, substituted thioctopyrimidine carbonitrile were prepared according to the scheme 1 also by reaction of multi-component of thiourea, ethyl cyanoacetate, and substituted benzaldehyde in absolute ethanol containing anhydrous potassium carbonate to give 2-thioctopyrimidine carbonitrile derivative that reacted with 2-chloroacetyl amino-thiazole derivative to further give the target compound hybrid. The target compound hybrid were elucidated through TLC, melting point, and high resolution mass, as well as carbon 13 NMR and proton NMR. The prepared hybrid will undertaking to investigate for their anti-inflammatory and anti-cancer activity, and investigate the anti-inflammatory by COX-1 and COX-2 inhibitory assay kits and lipoxygenase inhibitor assay kits to investigate their mechanism of action as anti-cancer and as anti-inflammatory. For anti-cancer, will undertake to do apoptosis and cell cycle analysis. For the anti-cancer and anti-inflammatory activity, molecular looking will done to correlate with biological kits assay. Thank you.
Today, it is of my pleasure to give you an overview about one of my research topics with the title Optimization of a Sensitive and Robust Strategy for Micellar Electrokinetic Chromatographic Analysis of Sofosbuvir in combination with its co-formulated hepatitis C antiviral drugs. In this work, we have developed a new strategy for the analysis of highly hydrophobic and basic analytes using hepatitis C antiviral drugs as model analytes. In this approach, we want to overcome the challenge which occurs due to the absorption of the highly hydrophobic basic analytes on the inner wall of the capillary. In addition, the separation of these compounds is very difficult using micellar electrokinetic chromatographic analysis because these compounds have a high distribution coefficient, so they are distributed mainly into the micellar core and migrate in the application of an electric field as a one single peak. Therefore, the main aim of this work is to develop a method for the separation of these studied analytes and to improve the sensitivity of the developed approach. As we can see here, these are the chemical structures of the investigated drugs, and with the exception of the sofosbuvir, which is a weakly acidic compound, the other compounds are highly hydrophobic and basic because they possess two basic moieties. Here in the Daclatazivir, 2-imidazole moieties, and in Lidivasvir, Elbasvir, and Vilbetazvir, we have imidazole and benzimidazole moieties. At the beginning, we have optimized the separation of these compounds by using a mobile phase system composed of 25 molar sodium glutathione sulfate in the presence of 10 millimolar borax and containing 20% acetonitrile. Acetonitrile is added as an organic modifier to reduce their distribution constant or their retention factors and shift the equilibrium towards the aqueous phase. And as we can see here, by using only 20% of acetonitrile, a successful separation of all of the studied drugs were achieved. Without the presence of the organic modifier, the studied compounds appear as a one single peak and migrate without any separation. The second step is to optimize the detection wavelengths. And as we can see here, for all of the studied drugs, 200 nanometer was the optimum detection wavelength. However, it is recommended in the analysis of biological fluids to improve the selectivity of the method and to avoid any interferences from the matrix component, to work at longer wavelengths, which is selected for these studied drugs, like, for example, 260 nanometer for sofosbuvir or 300 nanometer for Daclatazivir. Then the next step in order to optimize the method sensitivity is to optimize the composition of the sample matrix. And the composition of the sample matrix critically affect the performance of the online focusing mechanism. Here we have used pseudo-stationary ion exchange sweeping as an online enrichment mechanism. And in this mechanism, the sample zone is void from the micelles and the background electrolyte is, sample zone is void from the micelles and the background electrolyte contains the micelles. And to achieve the highest enrichment efficiency, the sample matrix should be acidic to impart the studied drug a positive charge, so the micelles, the negatively charged micelles, can interact with the positively charged drug or drugs via electrostatic interactions or hydrophobic interactions. Here we have tested two different sample composition. In the first one, we have used glutamic acid as the beta ionic buffering constituent and phosphoric acid as another acidic sample matrix. In the upper half of the figure, we have used a small sample injection volume, and in the lower half, we have used large sample injection volume. And under the two injection sample volumes conditions, as we can see here, the peak heights and the area in the presence of glutamic acid are much higher than that obtained in the presence of phosphoric acid. And this can be attributed to the co-ions present in the phosphoric acid or in the matrix containing phosphoric acid. So they compete with the target analyte on the ion exchange sites present on the micelles, resulting in lowering the retention factors in the sample matrix and subsequent lowering of the enrichment efficiency. So the glutamic acid was selected as an optimum sample matrix for the analysis of the studied drugs. The next step is to optimize the methanolic content within the sample zone. And as we can see here, we have tested 3 concentrations of methanol and compare the peak heights of the methanolic sample matrix with a sample matrix composed of or dissolved in the background electrolyte. As we can see here, in the presence of 2% methanol, the peak height were not that high, and the peak area also. And also the solubility of the drugs was not sufficient to reach the maximum focusing or enrichment efficiency. However, in the presence of 10% methanol, the peak area, peak shape, and peak heights were the optimum. In the presence of 20% methanol, the micelles start to disintegrate, result in lowering their retention factors and subsequent lowering of the sweeping efficiency. And in the background electrolyte, as the sample matrix contain micelles, there is no enrichment mechanism at all. Therefore, 10% methanol was selected as the optimum content of the sample matrix, as it can achieve 2 main advantages. The first one is that it keeps the solubility of the analyte, and at the second one, it achieves the optimum enrichment efficiency. And finally, to give you an overview about the difference between glutamic acid as a matrix or water or phosphate buffer prepared at the same pH as that of glutamic acid, we can see here in the lower sample injection volume, the optimum peak height, shape, and area was obtained in glutamic acid. In water and phosphate buffer, the peak shape are still reasonable, but they are lower than that obtained using glutamic acid. By increasing the sample injection volume, as we can see here, the peak were completely distorted in the presence of water, because here the micelles are interacting only with the drugs via hydrophobic forces. There is no electrostatic forces at all. And also in phosphate buffer, due to the presence of competing ions, it results in lowering of the interaction of the drugs with the positively or the oppositely charged micelles. Therefore, glutamic acid in the presence of 10% methanol was selected as an optimum sample matrix. So to summarize the online focusing mechanism, here we have injected the full volume of the capillary with the micellar background electrolyte, and then the sample zone was subsequently injected. And after application of a voltage, the drugs are migrating toward the cathode, whereas SDS micelles are migrating toward the anode and start to sweep the positively charged drugs within the sample zone toward the injection end. However, by the force of the electroosmotic flow, they are moving again toward the detection end, and the sweeping process is continued until all the analytes are focused within a small sample zone, as we can see here in this figure. And the dark green color indicates that the analyte zone are completely focused. And then additional focus of the zone occurs due to the difference in the retention factors of the analyte between the background electrolyte and between the sample zone. And in the remaining part of the capillary, the analytes are completely separated and finally detected. And as we can see here, we have obtained very good results regarding the limit of detection and limit of quantitation of these studied drugs, which is equal to 0.63 and 1.3 for sofosbuvir and declitesvir, and 1.3 and 2 0.5 microgram per ml in case of Ledivasvir and Velpatasvir. And the developed approach was successfully applied for the analysis of the studied drugs in pharmaceutical formulations, and also can be used for the analysis of the studied drugs in the presence of other drugs described in the treatment regimen of hepatitis C, like for example, ribavirin or Elbasvir. And here in this figure, we have carried out the analysis at different detection wavelengths. And as we can see here, the selectivity can be greatly improved if we work at 315 nanometer, so we can detect Daclatasvir without sofosbuvir and ribavirin. At the end, I would like to thank my co-authors, Professor Ota Piel, Professor of Analytical Chemistry, Marburg University, Germany, and Dr. Fatma Mustafa Abdelhel, an Assistant Professor of Pharmaceutical Analytical Chemistry, Asyut University. Thank you very much for your attention, and of course, your questions are greatly welcomed.
Assalamu alaikum wa rahmatullahi wa barakatuh. I'm going to present the poster entitled Design and Synthesis of 1,3,5 Tri-Substituted Indole Derivatives as Potential CDK Inhibitors. This work is a part of a master thesis supervised by Professor Dr. Tara Abulfadl, Dr. Ahmed Magdi, Dr. Hind Abulmagdi, and the student is Hani Mansour, Department of Medicinal Chemistry, Faculty of Pharmacy, Asyut University. CDKs plays a key role in cell progression and in transcription process, with 4 to 20-fold higher activity in carcinomas compared to normal tissue. So they are considered to be good targets for the design of anti-cancer agents. Also, azethins and 3-arylidine oxyindoles are at the heart of wide range of clinically used anti-cancer drugs. Of particular significance is sunitinib, which is clinically used as tyrosine kinase inhibitor. It was approved by the FDA in 2006. Simaxinib and other oxyindole derivatives are recently approved also by the FDA. Accordingly, we consider azethin and oxyindoles to be attractive scaffold for designing anti-cancer drugs. Herein, the design of our targeted compounds was based on molecular modeling and docking studies of each compound at the active site of CDK. The synthetic scheme and general structure of the synthesized compounds is shown in the presented poster. Most of the synthesized compounds were obtained as E and Z diastereoisomers and are shown in figures. These E and Z diastereoisomers are obtained with different ratios, and their resolution was achieved by column chromatography. The difference in chemical shifts and nuclear Overhauser effect between E and Z diastereoisomers is shown in figures also, and a representative example of H1 NMR and 2D NMR spectra is in the presented poster. For the biological screening, in vitro cytotoxicity screening against 5 cell lines was performed. Also, these synthesized compounds were screened on human normal cell lines to test their selectivity towards cancer cells. The obtained IC54 compounds showing greater inhibition percentage was performed. 3 compounds, which are 6A, 6B, 7I, 7P, showed IC50 values lower than that of the control drug, with the most potent one is 6B, with IC50 value 1.3 microgram per milli. It was on hepatic cell line. Thank you, and hope you enjoy this poster, and best wishes for you in our conference. Thank you.
Bismillah ar-Rahman ar-Rahim. Quinolones are well-known antibacterial chemotherapeutics that comprise several derivatives in clinical use. In addition to antibacterial activity, quinolones were reported for other non-classical activities such as anti-cancer activity, where voriloxin represents the first-in-class anti-cancer quinolone in clinical use. Quinolones act by disturbing the normal function of DNA topoisomerases, where antibacterial quinolones inhibit gyrase and topoisomerase 4, the bacterial type 2 topoisomerases, while anti-cancer derivatives target their mammalian counterparts. From structure-activity relationships study, it was clear that substitution at position 7 of quinolones has a major impact on these molecules. Position 7 was proposed to be responsible for direct interaction with topoisomerase enzyme in its complex with DNA, and substitution at such position can direct quinolones preferentially toward gyrase or topoisomerase 4, as well as it can increase affinity toward mammalian enzymes and hence potentiation of anti-cancer activity. In the present world, different derivatives of ciprofloxacin by substitution at the piperonyl in the 4 position have been synthesized in order to shift the biological profile of the parent drug toward anti-cancer activity, or obtain derivatives with dual antibacterial and urease inhibitory activity. The synthesized compounds were elucidated using different spectral techniques including IR, proton NMR, carbon-13 NMR, mass spectroscopy, and elemental analysis. Anti-cancer screening was evaluated in vitro by the National Cancer Institute at the United States of America. Among the synthesized compounds, derivative 3F and 3G experienced a potent anti-tumor activity against the breast cancer cell line PT549, as well as compound 3G revealed a remarkable anti-cancer activity against the colon cancer cell line HCT116. However, the test compound showed moderate to weak anti-tumor activity in general. Regarding antibacterial activity, the test compounds were less potent than parent against Klebsiella pneumoniae and Proteus mirabilis. However, compound 4A was more potent than the standard drug chloramphenicol. On the other hand, the majority of the synthesized compounds showed urease inhibitory activity better than their parent drug and comparable to the standard inhibitor Cyoria, where compound 3I was the most potent urease inhibitor with activity better than the standard. By docking study of the test compounds on urease enzyme from Helicobacter pylori, the test compound showed the ability to bind well with the binacle center of the enzyme active site, better than the standard inhibitor acetohydroxamic acid. Thank you.
You're welcome. I am Islam Salim. I am teaching assistant in chemistry department, Faculty of Science, National University, and I am a participating member in pharmacy conference. I am going to tell you about my project that is about synthesis, crystal structure, fluorescence properties, and anti-cancer activities of some new polysubstituted 5,6,7,8 tetrahydroisoquinoline. Isoquinoline alkaloids are natural and synthetic compounds. They have potent biological activities, including inhibition of proliferation cells, beta-adrenergic receptor antagonists, and inhibition of some enzymes related to catecholamine and endolamine, such as monoamino oxidase. In the last few decades, some of natural tetrahydroisoquinoline alkaloids that used as potent anti-tumor and antimicrobial have been isolated. Recently, some of potent antifungal tetrahydroisoquinoline have been synthesized. From these important biological and medicinal activities of tetrahydroisoquinoline alkaloids, our project was built on synthesis and study of crystal structure, fluorescence properties, and anti-cancer activities of these compounds. Our starting material had been synthesized according to reported method by Ozol in 1989. That synthesized from beta diketone cyclohexanone. Compound 1 reacted with cyanoacetylene to afford 5,6,7,8 tetrahydroisoquinoline compounds. Compound 2. This compound in basic medium is presented in equilibrium with the cellulose form. The cellulose form, the alkyl group, may be alkylated with different alkylating agents, such as ethyl chloroacetate. The compound 2, 5,6,7,8 tetrahydroisoquinoline, reacted with ethyl chloroacetate by SN2 alkylation reaction, where the sulfur atom expels the chlorine atom from the agent to form cyan ether compound 3. The cyan ether compound 3 has been obtained in new crystals. So we have studied the crystal structure of this compound as shown in the poster. The alkyl group may be alkylated with N-allyl to chloroacetamide in the same mechanism to afford the compounds 5-AUC as shown in scheme 2. Also, the alkyl group may be alkylated with the chloro compound of heterocyclic compounds, such as in benzoyl to chloroacetamide to afford the compound 7. The compound 7 has been obtained in new crystal. So we have studied the crystal structure of this compound as shown in the poster. The compound 3, 5-AUC and compound 7 contain important group that is methylene group. The methylene group has been activated by the withdrawal effect of the carbonyl group and the polarizing effect of the sulfur atom. So this group in presence of basic medium, strong basic medium of sodium oxide in ethanol in absolute ethanol solution has been added to the cyan group to give important heterocyclic compound of thionyl 5,6,7,8 tetrahydrocyanoisoquinoline compounds. Compounds 4, 6,8-C and compound 8. These compounds are important compounds. We have studied the anti-cancer activity of the cyanoisoquinoline compounds. We found that all cyanoisoquinoline compounds have anti-cancer activity, and the more potent one is the compound 3 that has the ethyl carboxylic group as the position 2, where it has IC15 equal 0.15 micromolar per liter. The we found that the cyanoisoquinoline compounds has fluorescence emission under visible and UV irradiation. So we now working on a study of fluorescence properties of these compounds, where we working on measure the photoluminescence of these compounds and calculation of the quantum yield. This is, we have found, we have reached to the end of our project. Finally, thank you for you all. I hope I could give you some benefits. Thank you.
Bismillahirrahmanirrahim. Rapid non-invasive determination of certain metronidazole combinations by FTIR spectroscopy. Nada Ahmed Yahya under supervision of Prof. Dr. Hassan Rifat, Prof. Dr. Hassan Asqal, Prof. Dr. Gamal Saleh. Abstract: FTIR method is a non-invasive method used for the first time to determine the combination of two binary mixtures, metronidazole ciprofloxacin and metronidazole spiramycin, in the solid state as a simple grain chemistry. The peak areas of the resolved bands of the FTIR spectrum of the drugs were used to quantify the binary mixtures. There were CN stretching band at 1075 cm-1 for metronidazole, stretching band of the carbonyl group at 1723 cm minus 1 for ciprofloxacin, and nitro stretching at 1535 cm minus 1 for metronidazole, stretching band of the carbonyl group at 1723 cm minus 1 for spiramycin. The chemical structure of the three compounds is shown in figure 1. Materials and the methods. All FTIR measurements were accomplished at Nicolette IS-10 spectrometer supplied with Omnic 8 Spectra software. Spectrograph software also used for visualization of the spectra in SPC format. Result and discussion. Figure 2 and figure 3 show the FTIR spectra of the binary mixtures in the region of 4000 to 400 cm minus 1. Figure 4, 5, 6, and 7 show characteristic well-resolved bands with no interference were used to quantify the binary mixtures. Figure 8 and figure 9 show the FTIR spectra of different concentrations of the binary mixtures. Table 1, the quantitative parameters for assay of studied drugs by FTIR spectroscopy in their pure forms. Table 2, the quantitative parameter for assay of the binary mixture by FTIR spectroscopy. Limit of detection were found to be 0.29 and 0.26 microgram per milligram for metronidazole and ciprofloxacin, and 0.2 and 0.65 microgram per milligram for metronidazole and spiramycin. Table 3. Recovery of standard drugs added to their dosage form using the proposed FTIR method show satisfactory recoveries percents with small relative errors and standard deviation. Table 4. Precision data for the analysis of the drugs by the proposed FTIR method revealed high precision of the proposed method at interday and intraday precision levels. Application of the proposed method for analysis of dosage form, ciprodiazole and spirazole force tablets was carried out and good results were obtained, and compared with reported method and show acceptable values. There were no significant difference between two methods of analysis. Conclusions. The results obtained from the present study indicated that FTIR as a non-destructive vibrational techniques was used successfully to investigate the combinations of metronidazole ciprofloxacin and metronidazole spiramycin in the solid state for the first time. FTIR spectroscopy could be attractive and potential alternative to other analytical methods for determination of such combinations in pure drugs, binary mixture, and dosage forms, because it was simple, rapid, low cost, could be applied without pre-treatment of the sample, and considered as powerful green chemistry due to deletion of organic solvent from the analytical procedure. This paper includes 21 references. Thank you.
Assalamu alaikum. I am Ahmed Farid, the lecturer of Pharmaceutical and Chemistry, Faculty of Pharmacy, Kafr Sheikh University. It's a pleasure for me to introduce my research article entitled Towards Understanding of Different Solid Forms of Formoterol Fumarate, Experimental and Theoretical Approach. In this research article, we have conducted in-depth vibrational spectroscopic investigation of different formoterol fumarate solvates, including diisopropanoate, diethanolate, and dihydrate, in addition to the anhydrous form. As well, Additionally, a crystallographic investigation has been conducted on anionic form as well as protonated anionic form of formoterol fumarate. All over the investigated forms, it was found that the dihydrate form possesses the highest energy among all studied forms. This could be attributed to the intermolecular and hydrogen bonding. In this study, theoretical studies have been carried out through density function theory. Experimental and theoretical spectra have been compared, and they provide a great match between each others. The structural analysis in this study provides much better understanding of formoterol fumarate structure that could be helpful in investigation of its interactions in pharmaceutical formulations. Thanks for attention.
My name is Sarah Ahmed Abdel Mohsen. I am a clinical pharmacist at the Oncology Department, Asyut University Hospitals. Our study is undertitled a randomized interventional study assessing the efficacy of vitamin B complex plus alpha lipoic acid as neuroprotective prophylaxis in reducing the development of oxaliplatin-induced peripheral neuropathy. Let's begin with introduction. Oxaliplatin, a third-generation platinum-based agent, is the principal chemotherapeutic agent for the treatment of colorectal cancer and also for other GIT cancer. Oxaliplatin-induced peripheral neuropathy remains the main dose-limiting factor for its use. The degree of peripheral neuropathy may be either acute reversible or cumulative chronic peripheral neuropathy. The aim of the study is investigation of the prophylactic effect of vitamin B complex plus alpha lipoic acid as neuroprotective agents on reducing the severity of oxaliplatin-induced peripheral neuropathy in cancer patients. Our methodology was a randomized interventional study was conducted on 136 patients attended at Oncology Department, Asyut University Hospital. Patients randomized into two groups. Group A, control, consisted of 68 patients take oxaliplatin chemotherapy regimen only, and the Group B, prophylactic, consisted of 68 patients take oxaliplatin chemotherapy regimen plus the prophylaxis. The primary outcome measures was the effect of prophylaxis on the degree of peripheral neuropathy, which assessed by nerve conduction study test and the clinical neurological examination according to National Cancer Institute common terminology criteria for adverse events. Outcome measures were assessed at baseline, after the third cycle, and after the sixth cycle of treatment. Our results showed that the mean of the age of studied patient was 46.82 plus minus 10.82 years. 55.9% were females versus 44.1% males. Compared to the baseline measurements, there was a clinically significant difference between the two groups, as Group B showed improvement of the degree of peripheral neuropathy compared to Group B. Also, according to nerve conduction study values, motor and sensory, Group A showed significantly abnormal values compared to Group B. 59% of Group B showed normal study compared to 28% of Group A. 60% of Group B suffered from sensory demyelinating neuropathy compared to 28% of Group A. And finally, 25% of Group B suffered from sensory axonal neuropathy compared to 44% of Group A. At the conclusion, using of vitamin B complex and alpha lipoic acid as neuroprotective prophylaxis appeared to be effective in reducing oxaliplatin-induced peripheral neuropathy in cancer patients and was well tolerated. Thank you.
شكرا جزيلا لجميع المشاركين في السيشن ده. ابحاث قيمه وان شاء الله يبقى ليها ابلكيشن في المجالات المختلفه لصناعه الدواء. اتفضل دكتور حسن.
شكرا جزيلا لكل الباحثين، ما شاء الله ابحاث كلها متميزه. طبعا لا يفضل ان احنا نشكر لجنه التنظيم للمؤتمر وعميد الكليه والدكتوره جيهان وكليه الشؤون العليا وكل المنظمين، وطبعا شركه فلور سبوت ما شاء الله عليها بذلت مجهود كبير معانا النهارده، وكل الرعاه الموجودين شركه ليبتس وصيدليات مراد جد الله وكل الرعاه الموجودين. شكرا جزيلا لحضراتكم. شكرا.